Hi, do we have the presenter on the paper in the title of data filtering method based on LSTM for non-water stress baseline estimation in real-time crop water stress monitoring? Okay. So do we have the last presenter here today? Last presenter on the title of K-means and morphological approach on image segmentation for fish detection. Okay, so maybe they will join later. Mr. Amare, please, could you please turn off the microphone first, please? Okay, so could you mute microphone? So in this section, we have, let me start by introducing our section here. This is a section of the architect digital technology for modern agriculture 1. This section will be organized online. We have 5 paper in this section. What we're gonna do here, we're gonna play the video on each presenter, and after that, we're gonna be questionings. So during the presentation, during the video playback, could you please mute your microphone, and you can turn it on. A presenter can turn it on during the questioning phase. So if the audience here have a question, but could not turn on your microphone, you can send me a chat message. I can ask each presenter for you. All right. So we're gonna start with the first work by Mr. Amaret. Oh, by the way, during the I would like to invite all the presenter to turn on the camera so that the audience can see who you are. All right. Once I start the video playback, please turn on your camera so that other people can see. So Mr. Amaret, please turn on your camera so that the audience can see you. All right. So staff, could you please start the first video presentation?
My name is Amalet Kapanya, working in Digital Agriculture Technology Research Team, National Electronics and Computer Technology Center. Today, I would like to present my paper on spherical-based 3-dimensional cassava root skeleton extraction. This work is a collaboration under Cassava Store project between NECTEC, Judith Forschungszentrum from German and Rayong Field Crop Research Center. The main objectives of development cassava variety are to obtain the cassava with high yield. The objective assessment are related to morphological measurement. Measuring the morphology of cassava roots by hands in traditional methods is a labor-intensive task. When computers can calculate faster, root morphology measurement techniques can be developed using digital image processing. Our work was to develop a system to measure the morphology of cassava roots using 3-dimensional image. The workflow of our system for measuring morphology of cassava root using 3-dimensional image begins with a video recording of cassava root made to rotate 360 degrees. 12 images from 12 angles were extracted from the video and were used to reconstruct a volumetric 3D image with voxel carving technique. Finally, the 3D image of the cassava roots was converted to 3D root skeletons to represent the center line of the roots and used to measure the cassava root morphology. three-dimensional image can be classified as surface, which has three-dimensional points only on the surface, and volumetric, where there are three-dimensional points inside the object. For a conventional method, a skeleton point is the centroid of the cross-section. A typical roots are cylindrical, resulting in an oval cross-section. Calculating the center of an oval cross-section yields the same result for both types of 3D image, but the cross-section at the root junction have an interdeterminate shape, and boundaries are much wider than the root portion. Thus, there is a chance to cause the skeleton point to move away from its proper path. To fix this problem, in the first place, a 3D image with volumetric points may be used with the previous cross-section plane, but the cross-section area may be too large, and the use of cross-sectional plane may computational complexity. Our skeleton extraction method based on spherical search can eliminate channel plane calculation and narrow the period cross-section area. Our searching sphere is set to guide the skeleton path to a specified destination, the root node. In order to find the skeleton, it is necessary to specify the ending point, which is the junction between the stem and the root, called a root node. But by observing the image, the root node is found in the thickness part of the image. The thickness part in the volumetric 3D image is the portion containing the largest number of the 3D points. Therefore, to measure the thickness of each segment of a 3D image, we can measure by counting the number of points surrounding it, and can be described in terms of point density. Finally, a method for estimating the coordinate of the root node is to find the centroid of the points with a density of 90% or higher. However, in a real 3D image, some parts are missing, especially in a small portion. The missing part form a floating skeleton that is separate from the original skeleton. This leads to wrong measurements. We must properly reconnect the floating skeleton to the original skeleton. We solve the reconnecting problem by searching for the original skeleton with the closest alignment to the floating skeleton. The method for finding a new skeleton point having distance r from the current skeleton point and directing to the root node. Start by finding spherical cross-section. The spherical cross-section is of points at a distance r from the current skeleton point. This results in front and rear cross-section. We only need the front cross-section. The method is simply by comparing the distance from the destination to the current skeleton point, or the current and the distance from the destination to the tested point, or the point. If the distance the point is smaller than the distance the current, then the tested point is in a front cross-section. If the distance the point is greater than the distance the current, then the tested point is in a rear cross-section. Then the new skeleton point is calculated from the centroid of the front cross-section points. If the new point have not reached the destination, the current point is shifted to the new skeleton point and then repeat the previous process. The benefit of calculating the skeleton points of each root separately is that the skeleton points of each root are grouped separately and ready for the root morphological calculation. Morphological measurement can be calculated from the root skeleton, including the number of roots distance from the root node to a root tip, a root radius, root depth, and root volume. Our skeleton extraction method has been verified with 3D image of cassava root to measure the performance. We inspected individual generated skeleton by eye. A various skeleton is divided as the following. One root is required to create only one skeleton. The generated skeleton must extend from the root stem junction to the root tip. If a floating skeleton occurs, it may be reconnected to the original skeleton correctly. Here is an example of invalid skeleton which does not extend to the root tip. Another example of an invalid skeleton shows that the path runs through multiple roots. To prove the working principle, the first experiment was conducted with 25 3D images of simulated cassava root. The total number of tested roots was 120 with 114 valid skeletons, so we achieved 95% of skeleton extraction accuracy. The total number of broken skeletons was 82, with 79 broken skeletons being reconnected. The reconnection accuracy was 96.3%. To measure the real performance, we tested with 50 3D images reconstructed from actual cassava root. The total number of generated skeletons was 515, with 452 valid skeletons. We achieved 87.8% of the skeleton extraction accuracy. The total number of broken skeletons was 39, with 34 broken skeletons being reconnected. The reconnection accuracy was 87.2%. Our skeleton extraction was performed on the 3D image of cassava root with 3D volumetric point cloud. Our technique used a 3D sphere to test along the 3D image of cassava roots. The skeleton extraction accuracy tested with the 3D image of simulated cassava root was 95% and tested with the 3D reconstruction of actual cassava root was 87.8%. In the future, this method may be applied to find the root test of other 3D volumetric point cloud such as turmeric and backingling. Thank you.
All right, we have about 2 minutes for questioning. Is there any question from the audience? You can raise your hand so that you can ask a question or you can send me a message, send a chat message, and then I can read it out for the author. All right. If not, I have one question I'd like to ask. For the whole process from begin to the finish, how long does it take for your algorithm to complete these processes?
It it depends on the number of point count, and if the number of point count is about 1 million point, the time to do that process is less than 30 seconds.
Oh, that is fast. That is
It's
fast.
very fast.
That is very fast. I have a question though. When you capture 3D image, there's a chance that one route can completely block another route, right?
Yes.
So in this case, can your approach handle this kind of occlusions?
Because my approach is not to do the 3D reconstruction. My approach is to use the 3D reconstruction and apply my algorithm to create the skeleton. And if the occlusion occur, it can be reconnected with the algorithm when the floating skeleton occur. That is the case.
Okay. So any question from the audience? If not, thank you very much. It's very good work. It's very interesting work that you have done. I hope that you can make more interesting work in the near future. Thank you very much. All right. So now we are moving to the second presenter. Second presenter is Mr. Kankamon. He will present the paper in the title of Grave Lead Disease Diagnosis using Convolutional Neural Network and Support Vector Machines. Mr. Kankamon is with the Faculty of Engineering, Faculty of Engineering and Technology, Rajamangala University, Technology Isan, Thailand. I think he is here. So the staff, could you please play the video? And I invite Mr. Kankamon to turn on his camera. Thank you.
Hello, everyone. My name is Kankamon Pukrongin. I'm from Rajamangala University of Technology. Today, we're going to talk about a combination between machine learning and deep learning. The topic of grave lead disease diagnosis using convolutional neural network and support vector machine. So the overview of the diagnosis system includes the three main processes that are input preparation, feature extraction, and disease classification. Before we get the disease output, we have to pass through the three main processes. So the first one is the input preparation process. It's used to normalize the size of original image from the original size to 227 multiple to 227 pixels and remove the background that we don't need it by freehand selection. Because the algorithm of CNN that we use has to fix the size of input with 227 multiple to 227 pixels. After that, the input that we send to the feature extraction process to get to the best feature of the disease selection. In the input will be processed through the convolutional filter that has been designed for Alex network. And finally, the feature coefficient that we got from Alex network will be used to build a classification model to predict the output by support vector machine. The architecture of the proposed algorithm is designed to automatically extract distinct features through the feature filtering by filter from Alex network. The feature extraction is divided into three important parts, such as the convolutional process, LERU, max pooling. In this research, we use the non-linear classification SVM, what is called the kernel, which is mapping their input into high-dimensional feature space to gain the mutual linear separation between every two classes, which break down the multi-class problem into multiple binary classification problems. The feature extraction process applies a convolutional function with various filters, consisting of 5 levels of convolutional, 3 levels of LERU, and 3 levels of max pooling, in order to decrease the number of parameters and maintain significant implication. For each filter level has different characteristics, while the output obtained from each level will be used as the input for the next layer. In the figure below show the diagram of operation of the distinct feature extractions of SVM. Output of the final layer of feature extraction process will be forwarded to the training process of the system, like as the ordinary SVM. And in this research, we use the Gaussian kernel with one versus OR method that give us the best result. The system of diagnosis process begins with the input image of cleft lip disease and sending to the SVM model that has been trained. Then the system will seek for the distinct feature of the cleft lip disease by convolutional process and classify them. So the experimental result from the table 1 show the test result of system efficiency of the Gaussian kernel with one versus all method. The results show the diagnosis from normal cleft lip with the accurate diagnosis rate equal to 100%. Downy disease with 87%, because downy distinctive features are vary and close to scab and rust. Rust disease with an accurate diagnosis rate equal to 94% and scab with 95.5%. And the test results show the overall accuracy value equal to 94.1% in average. And the figure on the right side showing the ROC curve of each cleft lip disease of the diagnosis system that show the system efficiency of diagnosis in all patterns of disease. The area under the curve are followed as normal cleft lip AUC is equal 1. For downy, the AUC is 0.98 and rust is equal to 0.9. And the last one, scab, is equal to 0.99, according to the test result of each disease from the table 1. So this research presents the convolutional support vector machine to potentially learn and classify information, the feature extraction process using the deep learning with convolutional neural network that can reduce the process, possibly causing operation errors in the machine learning, such as parameter selection and randomization of various parameters, which are time consuming for mutual testing. And find a dataset that's suitable for the training process. In addition, the model that we have proposed can be applied to all the group of image classification without parameter adjustment in terms of distinct features extraction. Besides, the kernel of SVM can be changed to suit for datasets required to the test of the system efficiency. Thank you.
All right, I think we have about 5 minutes for questions. Are there any questions from the audience? So you can either raise your hand or send a message to me or to everyone, to the author. Seems like we always have okay, there's one presenter would like to ask a question. Please turn on your microphone.
You hear me?
Yes.
Hello? All right. My question is that, is there a reason for you to use an image of 227 times 227 pixels?
That because the algorithm that we use has fixed design for this algorithm that we cannot change for the another side. It's just the purpose.
Oh, okay, thank you.
Okay, is there any other questions from the audience? Mr. Panpo, can you raise your hand, please? I don't know how to do that. Thank you very
I'm
much.
sorry.
I don't know how to do that. If not, I have one question though. Did you a few questions? First of all, have you tried different kernels in the SVM, and do they have different accuracies?
Yes. I tried another kind of kernel, but that we show on this paper is the best result of another kernel.
So how sensitive it is to the type of kernel that you choose?
It look like it's not different, just like 2 or 3%.
Okay, 2 to 3%.
Yes.
Okay, there's one question for the audience. Okay.
Hello, can you hear my voice?
Yes.
Yeah, I just want to know about the pre-processing process in this research before input in SVM, right?
Yep. Yes.
The pre-processing process or image processing that you use in here.
Sorry.
I think the question was, what did you do in the pre-processing process?
Okay. So in the pre-processing, we just erase the background by freehand copying, and just normalize the size of the input to 227, that like the visual, just to process.
All right. Did the author answer your question, Mr. Faifullah?
Yes, it's okay.
Okay.
Thank you so much.
Thank you.
I have follow-up questions. Not directly from his question though. Have you ever tried to train the deep neural network directly, as a convolutional neural network directly, and for the data set? Did you, without any SVM, have you ever tried?
Yes. If the accuracy is looks similar, but SVM is look better a little bit.
Right. I think I have found the same thing that the accuracy option using convolutional neural network in identifying a disease in plant are
Yes.
quite good.
Yeah.
Are quite good. I get like 98%, 95% accuracy is certainly can be achieved in most cases. But then do you think why SVM help improve the accuracy from the traditional convolutional neural network?
I think first of all, I try to combination between machine learning and deep learning. The first time that I try to make is another algorithm of machine learning, but in this case, I just try to use SVM instead of that, and it look quite good experiment that I just made this proposal.
Right. Okay. But we have time for one last question. Is there any question from the audience? Okay. If not, thank you very much. I think I have to call Dr. Right? Dr. Kankamon, right?
Yes, thank you.
I'm sorry. I have to call you Dr. Kankamon. I'm sorry. Thank you very much. All right. So let me move on to the next presenter. We have a third presenter. I think is Mr. Danish Kumar. He will present a paper on efficient net based convolutional neural network for virtual plant disease detections. Mr. Danish Kumar is with the School of Electrical and Electronic Engineering at University of Saint Sanet, Malaysia. All right. If the staff is ready, please play the video. Thank you.
A very good day to everyone, and Sawadee Krap to my Thailand friends over there. First of all, I would like to introduce my team. I myself, Dinesh Kumar, the presenter for today and also the first author of this manuscript. Next, let me introduce my co-author, Mr. Khairi Ishak and Mr. Iqmal Fitri. We are from University Science Malaysia, Penang. So my research title is on the efficient net-based convolution neural network for visual plant disease detection. So in this presentation, we will be sharing on a powerful deep learning based detector for the real-time plant disease diagnosis using plant dog datasets. The methodology provides a realistic and usable way for determining the class location of plant disease. There is a significant improvement over previous plant disease classification method. So next, move on to the next slide. I will be sharing on the overview of this presentation. The content of the slides throughout the presentation are problem statement, background of studies, objectives, methodology, result, conclusion, and also the future works or the upcoming works on the studies. Next, we move on to the next slide. Next would be the problem statement. Agriculture. Agriculture is one of the backbone of every country's economy. The first key thoughts of this study is to support to reduce the burden on the farmers. Farmers have a wide range of options when it comes to choosing acceptable crops and finding the right treatment and insecticide for their plants. Plant disease causes a significant decline in the quality and production of agriculture products. Plant disease research is concerned with the analysis of visually identifiable pattern on the plants. If we produce less quality and unhealthy plants, so there will be a decline trend will be produced on the profit and impact the both farmers and the country economy and growth. So next we move on to the next slide. In this slide, I will be presenting on the previous studies. As we are seeing here, it's showing the percentages of accuracy versus the model and pre-trained weights applied for the plant disease detection. The short-term PVD here refers to plant village dataset. Model VGG16 with ImageNet plus PVD pre-trained weights obtains 60.41% of accuracy. Next, on the Inception V3 with ImageNet plus PVD obtained an accuracy rate of 62.06%. Based on the latest study by Practical, the combination of Inception ResNet V2 with ImageNet plus PVD gained the most accuracy with 70.53% on the plant disease detection. Next, we move on to the next slide. Next would be the objective of this study. There are three main objectives. So first objective is to study the transfer learning performance with ImageNet and Plant Village dataset for plant disease detection. The next objective is to understand the PlantDoc dataset and Plant Village dataset performance with EfficientNet version 1 versus EfficientNet version 2. The third objective is to understand the transfer learning based detector for real-time plant disease detection and implementation. So next, move on to next slide. Next is the methodology on the experiment setup. In this experiment, all training setting and configuration are applied in the Python-based PyTorch library, while the hardware platform is Google Colab. We also use scikit-learn to numerically analyze our evaluation. Colab offers a Jupyter Notebook service as well as parallel computing resources for machine learning or the model training. Google Colab provides free usage of graphic processing units, which is a GPU, and the type of the GPU used for the model is Tesla K80 with the 12 GB of memory. Next, for the experiment, we have repeated the experiment for 3 sets. Each set contains 10 times of data collections. The accuracy and the F1 score results have been evaluated by the careful cross-validation method with 10-fold cross-validation under scikit-learn analysis. This validation method applied to these 6 experiment setups. In this slide, I will be presenting on the dataset details. So in this study, we have used PlantDoc dataset, which is PD, and Plant Village dataset, which is PVD. In PD dataset, there are a total of 9,216 images with 27 classes of diseases and 13 species. While for PVD, we have 54,306 images with 38 classes. All images are resized. The PD dataset resized to 100 by 100 pixel and the PVD resized to 256 times 256 pixels to standardize the image sizes to ease the experiment. In this slide, I will be explain the experiment setup and the result of each test setups. There are 2 models being used for the experiment, which is EfficientNet version 1 and EfficientNet version 2. EfficientNet with pre-trained ImageNet weights by applying 80% images from training set and 20% of test set from PlantDoc dataset, which is obtained the least accuracy score of 37.30%. Next, we have changed the experiment setup for the pre-trained weights. So then the resetup of the experiment done by applying the EfficientNet version 1 with the ImageNet plus PVD pre-trained weights. But the percentage of the images segregated before remains static, or we can say unchanged. For this setup, we have gained the accuracy rate of 65.02%. So this setup output is a bit better result if compared to the previous setup. Next, this experiment extended to another 3 more setups with the EfficientNet V2, which is a similar setup as we set before for the EfficientNet V1. As we can see here, the model of EfficientNet with the pre-trained weights with combination of ImageNet and PVD obtain the most highest accuracy value of 74% if compared to the other 5 setups which have been experimented before. So in this slide, I will be explaining on the graph of performance which have been gained after the experiment. So there are two graphs, which is one is for the accuracy and one is for the F1 score. So as we can see here, the highest score have been gained by the combination of the EfficientNet version 2 with the ImageNet plus PVD. So for the F1 score, the rate of F1 score still indicating the ImageNet plus PVD with the model of EfficientNet gaining the highest accuracy scores if compared to the other 5 experiment setups. In this slide, I will be explaining on the proposed solution compared with the previous work. So first of all, for the VGG 16, we obtain an accuracy of 60.41%. Next is the Inception version 3, we gain the accuracy of 62.06%. For the third is the Inception ResNet version 2 with the 72.53 accuracy score. So the last one is the EfficientNet version 2, which have been proposed solution for this study with the combination of pre-trained weight, ImageNet plus PVD, and also the 80% from the training set of the plant.doc data set and the 20% of the test set plant.doc data sets obtain an accuracy of 70.03% at the end of the experiment. So as we can see, EfficientNet V2 scores the highest accuracy rate if compared to the VGG16, which is obtained 60.41%. So next, move on to the next slide. As a conclusion, as we can say that the upgraded EfficientNet, which is the EfficientNet V2 architecture, is more efficient, high speed and accurate compared with the EfficientNet V1. Besides that, the pre-trained weights are also influencing in the experiment or the score rate of the accuracy. So the as we can see, the pre-trained weight combination of ImageNet and Plant Village are obtaining the most highest score in both experiment setup. So the highest score obtained for this final experiment with these combinations are 74%. So next, move on to next slide. So for the future work, we are planning and undergoing a study to implement this in the real-time image processing with the movable platform for the agriculture usage. Thank you for your valuable time to listening to my presentation. Thank you and have a great day ahead. Thank you.
All right. So it's time for questioning. Is there any question from the audience? Okay, there one question. Please go ahead.
Hello, I would like to ask that you got an accuracy of 74%. How would you plan to improve the accuracy? And also, is that the case of imbalanced data, and would the model be underfit?
Can you repeat your question? It's like, yeah, it's a bit not clear.
Wait a minute, I'm gonna switch my.
So there were two questions, right? One is that do you have any plan for further improve the accuracy? That's the first question. Did I get it right? Right. The second one is, if the data is imbalanced, would your model be underfit?
Okay. So for the improvement in future, so accuracy rate can be I mean the performance rate can be improvised whenever we are having a lot of data sets. Well, for example, we have a good data set, so there will be the performance we will get the more accurate, and also the learning curve of the algo will be more effective if compared to the minor range of the data set. Besides that, the scale and the size of the data sets are also impacting on the performance and accuracy. So what we are planning in future is something like to standardize the image size for the to increase the performance, because currently we are getting the 74.0% based on the previous benchmark set up for the from the VGG 16 Inception 3 and also the Inception ResNet version 2. So we are benchmarking from this, and then we obtain a better performance result and accuracy rate from the previous studies. So this is what we have done for these studies. Yeah. Is it? Did I answer your question?
There's one question, another question though about imbalance data set. Would your model be underfit?
Actually, this is still under improvisation. So we are still not putting it as under fit for the performance rate, because it's still with this transfer learning, it's still getting a better performance accuracy if compared to the previous works. So we still acceptable for this performance rate. So, but in future we still can improve the percentage of the accuracy, because when it comes for the movable platform, so it have to be more tangible way to, and also like it have to be more accurate if we are implementing in the movable platform. Yeah.
All right.
Okay. Thank you for your answer.
Thank you for both author and the questioners. All right. Time is up, so we have to move on to the next presenter. If people have more questions with the author, you can send direct message to him via our chat in the WebEx. All right. Okay. Thank you very much.
Okay. Yeah. Thank you.
Okay. Let me move on to the next presenter, Mr. Panupong. Staff, would you please play the video?
Hello everyone, I'm Panpong Wipot, a master degree student of Thai Stochastic program. Today I would like to present our research, which is called Data Filtering Method based on LSTM for non-potential stress baseline estimation in real-time crop water stress monitoring. In order to explain our project, I have divided the topics to 5 topics, which are introduction, background, purpose method, experiment and result, and finally the conclusion. So let's start with the introduction. In agricultural production, the effect of stress due to insufficient water can lead to many things, such as deficiency in growth of the crops. It can also lower the yields of the crops, and in worst case, it can cause permanent damage or death to the crops. Therefore, in order to determine the crop water status and to quantify the crop water stress, the crop water status index was developed. And following that method proposed by Diesel et al., we try to find a relationship between canopy air temperature difference and the vapor pressure deficit of a tutoring tree. And as you can see that the data points scatter along the x-axis. And when we try to use the linear equations on this set of data and use it to find the CDBS side, it shows no correlation between CDBS side and the stem water potential of the tutoring tree. Therefore, this research aims to develop a data cleansing framework which can provide strong correlation between CDBS side and stem water potential. So let's talk about the background. First, the crop water stress index can be calculated using the following equation, where Tc is the canopy temperature, Ta is the air temperature, and Tc minus Ta lower bound is the nominal stress baseline, or the NUSB, the green line here on the figure. The Cc minus Ta upper bound which is photo stress baseline or WSB, which is this red line here. And the VPD is vapor pressure deficit. This VSI is varied between 0 and 1. 0 means that the crop is under non-stress condition, and 1 means that this crop is under stress condition. And in our purpose method, we'll include the long short-term memory into the framework. So the LSM structure are defined as the following equation here, where the CT is the memory cell, the HT is the working memory, the XT is the current input, the ST-1 is the former state information, the IT is the input gate, the OT is the output gate, the FT is the forget gate, the CT is the new candidate state, WF, WI, WC, and WO are the ways of the forget gate, the input gate, the new candidate state, and the output gate, respectively. The BF, BI, BC, and BO are biases of forget gate, input gate, new candidate state, and the output gate, respectively. And finally, the sigma is the sigmoid function. So let's talk about our purpose method. So first, in order to create an clear sky Earth model, this model was trained by the Earth datasets which are under clear sky condition, and this model will be able to generate the predicted irradiance or IPRED, and this parameter will be compared with the observed irradiance, and then we will judge if the data is under clear sky or not by observe the difference between these two. If the difference is large, it means that this data is not under clear sky condition. And in order for the model to be accurate all the time, we will let the model be updated by both by either the IPRED or the IObserved, depending on the error. Where if the IPRED is more than the IObserved, the model will be updated using IPRED. And if the IPRED is equal to or less than the IObserved, the model will be updated using the IObserved. And this is the result of the model where the top figure is when the irradiance is under cloudy sky, and the bottom figure is when the irradiance is under cloudy sky. So the concept of our purpose method will concern these parameters, where the air temperature under during bush is labeled as TC, the air temperature at vegetation as TA, the air relative humidity under during bush as RS bush, the air relative humidity as RSA, the air density as I, the stream water potential as psi S, the vapor pressure deficit as VPD, the wind speed at W, and the flow of our firmware is shown here. The first step is that we will import the dataset of the VPD, the TC minus TA, the RHA, the IS both, the I, and the U with respect to time in ascending order, and then divide and separate them day by day. Then we will consider if these data points follow this condition or not, and the conditions are the data must be between 7 to 10 a.m. It must be under wind speed under 6 km/h. It's the absolute difference between RSA and RS bush must be lower or equal to 12%. The difference between IPRED and IObserved must be less than or equal to 50 watts per meter square. If the data are under all these conditions, they will be used to estimate NWSB, and then we will assume the SB to be equal to 1 because we have conducted an experiment where we intentionally not provide the durian tree any water for 9 consecutive days, and it shows that the maximum temperature is at 1 degree Celsius. So we will use this NVSP and WSP to collect the severe side. And this is the result of NVSP from 4 different approach, where A and C follow the ISO method. The difference is that the A is when we didn't filter the data, and C is when the data is already filtered. And B and D are the method that we proposed, and B is not filtered yet, and D is when the data is already filtered. So the experiment is conducted at Canterbury Cultural Research Center on the Durian tree, where the Durian tree is located in the Durian orchard, and we selected this column of trees and select the tree number 5 right here. And this research is under quality project called the Irrigation for Point Oak between Thailand, Germany, and Myanmar, which launched since July 2020. And all these parameters are recorded at sampling rate equal to 5 minutes. And all these are the sensors and tools to measure these parameters. So to evaluate the severe accuracy from our proposed method, we will find the correlation between severe side and the same water potential. And the figures here shows the correlation between severe side and 5S on December 6th, 2020. And it shows that the correlation on this day is equal to negative 0.85. And this result is found during 6 a.m. to 6 p.m. And then we try to compare result from 4 different methods. And this correlation coefficient was calculated only on certain days following the condition. This data is between November 2020 to February 2021 based on the value of 5S from 6 a.m. to 6 p.m. The 5S must not be equal to 0 megapascal for longer than 4 hours consecutively. And as a result, we were able to show you 20 days of result in total. So this table shows the correlation coefficient between CSI and 5S on 4 different methods of 20 days. And the result of the average result shows that our proposed method shows the strongest correlation of negative 0.65 in average. So in conclusion, when we use the proposed method followed ISO, it shows that the relationship between severe side and between the TC-CA and VPD is scattered. And when we use the lake negation to find the severe side, it shows no correlation between severe side and 5S. But when we try to use our proposed method, it shows some correlation between severe side and 5S, which is equal to minus 0.65 on average, but the results were not consistent. So that's it for our presentation. Thank you for your attention. If you have any question, please feel free to ask.
All right, thank you. I think we have time for one or two questions. So any question from the audience? All right, I'm wondering how can you measure this that 5S? I'm not quite clear. How did you measure the 5S?
Oh, we're using something called what is it called? I forgot the name. we carve the stem of the 23, and then we plant sensor. I got the name. What is it called? I'm sorry, I forgot the name.
So it's a direct measurement on the tree.
Yes, it's
All right.
you just put on the stem. I mean,
On the stem.
on directly. Yes.
So I see the graph, like there were like a nice correlation between CWI, right? And then
Yes.
yes, and then get it saturated. Can you explain to us what happened though?
Can you repeat the
I
question?
saw in your PowerPoint there like I see that there's like for the low value of 5S, there seems to be very high correlation between or the measure value and the, what you get from these CWI, and after that gets flattened. Can you explain to us what happened? I think it was figure.
Just for the moment.
I think figure 3D, I guess, in your paper. I think like this nice correlation at lower value and then get saturated.
Saturated, or you mean when the let's see, when the value of the stem potential is let's say a lot, no, very small, like very small, or you mean a lot, because there are two situations. I mean the when the upper part where the saturation is about around at minus 0.2 megapascal, and then there is another one at saturation about minus 0.6. So you mean the upper one and the lower one, right?
I think I'm sorry. I think I'll talk to you a bit later. I think time is up. I'm sorry because I don't want to
sorry about that.
center time. All right. So because let me move on to the last presenter. I think okay. I think we have one last paper here. It's gonna present by Mr. Sofan Saifullah from the Department of Informatics. I'm sorry if I cannot pronounce your university incorrectly. Universitas Pembano Wasino Wota.
Pembangunan Veteran Yogyakarta.
I'm sorry. So the paper entitled of K-mean Phonological Approach on Image Segmentation for Fish Detection. So I'm sorry for that. Hard for us to pronounce. So the staff, could you please play the video?
Hello everyone, my name is Sofan Saifullah. I'm from Department of Informatics, Universitas Pembangunan Nasional Veteran Yogyakarta in Indonesia. Thanks for the opportunity and the time for me to present in international conference on electrical engineering or electronics, computer, telecommunication, and information technology. Especially my research is Cummins and morphological approach on image segmentation for face detection. In here, I have an outline of my presentations. We have 4 parts. The first is introduction. In introduction, we are talking about the background, problem, and the cap of this research. And the second, we are talking about the dataset and methods. The dataset we have used in secondary data from the QT first dataset and Yao et al. Research. And the second is about the methods of the research, especially in Cummins segmentation and morphology based on the image processing. And the third, we are talking about the result and discussion. The first, image processing, colors image for Cummins segmentation. Second, image preprocessing, morphology, and the age detection. And the last is about the conclusion of this result and the future work. The introduction, based on the segmentation, needs increased quality image to get an optimum object detection by the preprocessing. It caused the result of the image acquisition does not always have a good quality, such as the image has a blur, unclear, broken, too dark, or break, etc. The image requires preprocessing to improve quality without changing the critical information before the segmentation method. First, face detection can be processed by various methods such as probability model, machine learning or deep learning and the image segmentation, this previous method based on the previous research. This research, especially in here, we are aims to segment the image using the coming and morphology in face detection and development of the previous research with the edge on the method, especially in a blur image and the face detection, especially of the detects to the object of face. The next is about the previously. The researcher conduct a segmentation using the coming and morphology methods. This research extend the previous research with a single and limited face detection, especially in a face image object in 100 dataset by applying the image enhancement. We have two methods, CLAHA, HA. They are a contrast limited additive histogram acquisition and histogram acquisition. In addition, the Cummins method can be approved by the LAB color space and also they can segment and detect the first, and the HSV color is also used in the coefficient classification and it can be implemented. Subframe algorithm can also be used for face detection by segmenting the first object. This study developed the previous research by processing color and grayscale, especially in image acquisition from the 100 data images. This is our dataset and methods. So the dataset we have used the secondary data was obtained from the Qt first dataset, and we can check by wiki.qt.edu.eu, display rack face plus dataset, and Yeo et al. From the especially in the researches previously. In here, we are talking about the dataset. We use to load data image to process for the first image pre-processing. They are just the image reshaping and image resizing, and then we will do process by the image grayscaling if we are good concept for the grayscaling, and we use the second process to common clustering based on the color image, and then we are use image adjustment and image enhancement for the second previous second pre-processing. In here, we are talking about the how to histogram acquisition will be increased and to get the image, the best image to process by the segmentation in the morphology and edge detection. And the morphology we are use the opening, closing, thickening, and the edge detection we are use the canny edge detection. And the last we the image segmentation in our research, especially in here. And the common process we will to get the process from the 5 step. Like the first is initial with the number of the gap value, just the key of the centroid point of this image, especially the matrix, with randomly for the first, and update the centroid point value to make a grid the best the centroid point, and group by the chi clustering, and repeat the process from the centroid point to get the optimal of the centroid point. This is about the sample of dataset that we are used in our research. This is from the Yao and the Qt dataset image. This is about our result and discussion. The first image pre-processing, we are use the resizing and of this image dataset to make a clear and effective, especially to make a test of the processes. And second, we have the color image common segmentation. In the common clustering performs segmentation process in a color images loop in 3 times, because the color have a 3 component, red, green, and blue. The scenarios of the key value ranging from the 2 until the 10, and get the best segmentation of the result in K is H. This is for the example for the result of our process, especially in the common segmentation on the grayscale. This is in the grayscale and this is in the color image. The K less than H produce a segmented image with a cut then that do not match in the image, so the image have a blur result. Meanwhile, if we have a value of the K more than H, the result produced have an additional area and the segmented object, so that the detect object is doesn't match for the result. And the second image processing, based on the previous result, based on the color image, the histogram has been distribution of the color image histogram of the combined from the three color, red, green, and blue. In contrast, a gray scale image from the first pre-processing can be improved by GLHAHE methods. The distribution of the value have been between 0 until 1, and the maximal intensity of this pixel is 150. The GLHAHE methods or image enhancement method that we are used produce a more precise image and are easier to process. This is for the result of the histogram of the combine of the color in a resized image, and then the segmented image result that we can make a clear in a histogram. And the last is about the grayscale on the common segmentation that we have processed in here. And this is about the result of histogram of GLHA, and this is the combine of the GLSA. From the GLSA, we have spirit of the number of metrics like here. The spirit of the histogram is not to average or, and we will to continue by the HLA. So we have two combine of the methods HA. In here, based on the process of the histogram acquisition or image enhancement, we have the image result from this process in after the image pre-processing. The first is image result that we have got in a GLHA, and this is for the combine of GLSA SA, and this is for the conversion from the GLSA SA to get the image before the segmentation by morphology and its detection. So based on the previous result, the first image that we get the result, we will to process by the morphology and its detection. The morphology, we have three operators: opening, closing, and thickening, and we get a result like that. So the result for the morphology, we will to make to create an its detection like in figure B. So this is the last process, and we can show the image field of the text of the first. The morphology produces an image. The whole still need to be closed using the thickening operation following by the Kenny-Edge detection. These methods can be implemented in this image medicine process in obtaining an underwater image. So the last result that of my research is calculated by the SSIM and the accuracy. Based on the SSIM, saw the distribution value between 0.9 until to 1, with the average value being 0.99. This result indicates that the segmentation process an image of data information that almost the same. This is an unchanged. So the applying the Kalman segmentation and morphology can contribute to acceptable result to fish detection. In addition, the accuracy of the calculation using the detection success defined by the total of trial from the sample data. In here, we are talking about the accuracy. The total average of this process have value 84.48% to all of scenario process of this Kalman segmentation to detect the first. And the last is about the conclusion. The Kalman segmentation produces the segmented fish with the K optimal is 8. And the second, for this conclusion, the first image preprocessing used image resizing and reshaping to increase the effective and speed of the Kalman segmentation, the color and grayscale image, but still have weakness. So it should be processed by the second image preprocessing, use the GLHA to improve the image quality. The next is the process using the morphology and extraction method. The final result show the object detail can be seen clearly and can divide the first fish object from the background. The effect of the SSIM is 0.9 more than 0.99, and the accuracy is more than 84%. So this calculation indicate that the method that we are implement or we are used in this research in image segmentation, but the accuracy need to be improved. For the future image, for the future works, the segmentation will be used to support vector machine for the fertility its detection.
All right, I think we have only time for only one question. All right, so I think then I'll ask one question though. So I just wondering about the data set, how many species of fishes in this data set? Can you hear me? I couldn't hear you. I think you didn't turn on the the microphone. You have to unmute the microphone first.
Hello, can you hear me?
Yes, I can.
The dataset that we are used in here in this research is only 200 of dataset from secondary dataset from QT fish dataset and the research by Yao et al.
So you mean there are 2 species or 2 image, 200 image? There are 200 image species of fish, or there are 200 images? I wasn't clear. What did you say? There are 200 species of fishes or 200 images. I wasn't.
200 images of the image. The image is only have one fish.
One fish.
And one detection.
Okay. Or one fish per one.
Yeah, one fish, one image.
One fish, one image.
From the dataset that we are using here.
That is hard. The dataset is very limited.
Yeah.
And all of them are in the sideways. I mean, all the images are captured sideways of the. I mean, on the side of the fish. Or there are a different angle of fish.
The size is
No. I mean the post. I mean.
Yeah.
Seems like the image are on the side of the fish, not on the top or on the left, on the front side of fish.
The kind of the position of the angle of the first that we can detect of the edge of the angels, if the in front of or in the left, like left or right, and the first can detection by the Kalman's and morphology approach that we are using here.
Okay. All right. I think time is up. I think it would be great if we have more time. So I conclude, then I have to conclude this section. Thank you all the presenter that join our section here. And thank you audience that participate in this section. Unfortunately, I forgot to introduce myself. My name is Thirasit Kaset. I'm from Kasetsart University in Bangkok. My main research focus is on image processing and architect in general. So I'm working on remote sensing, image classification, crop disease classification. All right. So thank you. Hope to see you more in the next year conference. Okay. Goodbye. So, oh, by the way, we have opening. I forgot to tell. We have opening ceremony at 10:40. I hope everyone can join. All right. Goodbye.
Okay. Now we have more 10 minutes before the session will start. Let me check for the first paper. I think some of the first paper is in this room, so we can start the session, and I think they can answer some question after finish the playback video. Okay. Let us start the playback the first video from the first paper. Okay.
Hello, ladies and gentlemen. Welcome to my presentation. My name is Professor Dr. Shahram Minai. I am from Turkey, Istanbul, from Doğuş University, Department of Electrical and Electronics Engineering. Also, my co-authors are from Pamukkale University, Department of Electrical and Electronics Engineering, Dr. Erkan Yüce and Dr. Halil Alparslan. The title of my presentation is CFOA-based floating simulator suitable for realizing frequency-dependent negative resistor. The contents of my presentation includes first an introduction is given, then the introduced floating simulator is presented, and an application for our proposed floating simulator is shown, and then we give some simulation results for our circuits, and finally a conclusion is given. For processing, transporting, filtering, amplitude and frequency change of analog signals, we need to develop some new various active building blocks. Among the active building blocks, the current feedback operation amplifier, with the abbreviation of CFOA, is a well-known device. It has experimentally feasibility and has a good stability and can be found easily in market and can operate at high frequency and has a good bandwidth. Regarding with the FDNR circuits, the FDNR circuits in the literature have some disadvantages. These disadvantages can be given as the use of more than 3 AD844s. And the other one is requirement of passive component matching restriction, and number of passive elements in some realization is high, are not canonical, and some active building blocks in some design are not commercially available, and some structures are not lossless. They give lossy FDNR circuits. The symbol of the CFOA is shown in this figure, figure 1, and you can see that we have 4 terminals, Vx, Vy, Vz, and Vw, and the currents are Ex, Ey, Ez, and Ew. The relationship between the voltage and currents are given here, and the proposed circuit for realizing a floating simulator is given in figure 2. Here you can see that 3 CFOs are employed, and we also need 3 admittances as Y1, Y2, and Y3. We can select different passive elements instead of the admittances. For example, if we use a capacitor instead of Y1 and a capacitor instead of Y2 and a resistor instead of Y3, so the matrix equation is obtained as given here in equation 2. And you can see that we have a term of S square C1 C2, which means here we have a frequency dependent negative resistor with value of D. D is equal to C1 C2 R. And in figure 3, the electrical symbol of the FDNR is shown. For more investigation, non-ideal analysis of the proposed circuit is also given in the paper. The non-ideal analysis is performed by assuming that Vx is equal to beta times Vy, W is equal to eta Vz, Iz is equal to alpha Ex, and Iy is equal to 0. If we use these parameters, so our matrix equation is changed to the formula given here, and you can see that the parameter will affect the matrix equation. As an application, the introduced floating FDNR is placed in a voltage mode bandpass filter, second order bandpass filter as given here. You can see our FDNR is here, and it is in series with the resistor capacitor, and the output voltage is given across the capacitor. The transfer function of this circuit is given in equation 4. As you can see, it is a bandpass filter. In order to simulate our CFOR and our circuit, we use the CMOS structure given in figure 5 structure for simulating the current feedback operational amplifier. This structure, CMOS structure, is obtained from the reference 15 here, and we use 0.18 micrometer TSMC CMOS technology parameters. The power supplies are equal to 1.25 and minus 1.25, and non-ideal DC gains of this internal structure are obtained as given here. For example, beta 0 and eta 0 are equal to 0.985, and so. The aspect ratios of the PMOS and NMOS transistors can also be found in the paper. Here is a summary of the aspect ratios of the MOS transistor. For example, for PMOS, it is equal to 15 micrometer divided by 5 micrometer, but for the NMOS, it's equal to 5 micrometer divided by 0.5 micrometer. And for the FDNR circuit, we selected C1 and C2 equal to 100 picofarad and R equal to 1 kilo ohm. That results in a FDNR value equal to 10 to power minus 17 farad at second. The phase response and magnitude response of the proposed FDNR circuit is given in figure 6. As you can see, we have an ideal response here in this region between 100 kHz and 10 MHz for the phase, which is equal to minus 180 degree, and for the magnitude, the same is valid. And so we can say that our circuit works well between 100 kHz and 10 MHz. And the power consumption is around 3.3 milliwatt. In addition, the performance of our circuit with respect to the change of the temperature, for example, from minus 30 degrees to 120 degrees. And also the performance of circuit with respect to the change of the power supply from 1 volt to 1.5 volt with 0.1 volt steps are given in figures 7 and 8 respectively. And you can see that there is small deviations from the ideal curves in both AC temperature response and AC response to the variation of the power supply. And also Monte Carlo analysis with 100 runs is performed, and as you can see with 10% deviation for the passive components is applied to the circuit, and you can see that again small deviations is appeared on the figures. For the bandpass filter, voltage mode bandpass filter, we selected the given capacitor as 0.1 nanofarad and RF 4 kilo ohm. And for the FDNR, the selected values are 250 ohm and capacitors are equal to 100 picofarad. And now we can see the result. Here in figure 10, you can see the phase response and gain response of the voltage mode bandpass filter with ideal and simulated responses both are given in the figure. Also, the time domain response of the filter is given here in figure 11, and you can see that an input voltage of around 100 millivolt sinusoidal is applied, and again the output voltage is given here. Finally, as conclusion, in this presentation we proposed a floating FDNR composed of 3 CFOAs, only 1 resistor and 2 capacitors. This number of passive elements is canonical, and the circuit does not need any passive component matching constraint, so makes it suitable for IC processing. Also, ideal and simulation responses are in a match with each other, quite agree, but the differences can be attributed to the non-idealities of the CFO. Thank you very much for your participation in our presentation.
Okay, thank you very much, Professor Sharem. And could you turn on already? What time in Turkey and now? What time?
The time is 15 minutes past 10 o'clock.
Oh, okay. Thank you for your joining us. Do you have any question from the audience? Any question? Okay. Let me ask first question. You mentioned in the introduction that CFOA can be available in the indicator circuit, right? For example, AD844, right?
Yes.
Yeah. Why in this work you did not use AD844 for practical implementation? Why you use a CMOS implementation in this work?
Yes, because actually we decide to realize this circuit with CMOS. The available CFOA is in BJT technology, but we designed an internal structure, but CMOS one for CFOA, which dissipate lower power consumption than commercially available CFOs. In future, one can construct and the chip of this IC of this circuit can be produced. Then lower power consumptions and better performances can be obtained. So we designed our CFOA in CMOS technology.
Okay, thank you. How about the THD in the figure 1? THD, total harmonic distortion, in figure 1.
Total harmonic distortion is around 1%.
Oh, okay.
Around 1%, yes. For low and medium amplitude of the sinusoidals, it is given in the paper, but it is not so high. So from the total harmonic distortion point of view, the paper, the circuit works good.
Oh, okay, thank you. Maybe last question for me. What is the 10% uniform deviation for Monte Carlo? 10% uniform deviation.
Yes.
You mean your channel C1, C2, and also R together, right?
Yes, it means that, as you told, it means that all of the passive elements change with the same rate, and this changes 10% of its nominal value deviation, and it is uniform and like a white noise, uniform, and applied to all of the passive elements to capacitors and resistors at the same time.
Okay. Okay. It means that we change the T value together, right? T value of C1, C2, and R in the same time, right?
Yes.
Okay. Thank you. Anyone have question for the first paper? Anyone? Okay. Thank you for your presentation and
thank you,
answer.
Mr. Chairman, from you, and I wish a very good day in Thailand. Please forgive us because we couldn't attend the conference personally, physically, but this is due to the problems that you know. And
we know.
Maybe next week, next year, we will participate. Thank you so much, Mr. Chairman, and have a good day.
In the title of mixed mode universal filter using different transconductance amplifier. This paper, they want to present here, not for video, right? The presenter is the Pichai Saksai-Bun. Okay, are you ready?
Saksai-Bun, yeah.
Okay, are you ready? Can you share your presentation?
Okay.
I think that everyone can see your PowerPoint presentation. So if you are ready, you can present. You can start now.
Okay, thank you, Mr. Chairman, and good afternoon, ladies and gentlemen. My name is Pichai Saksai-Bun. My advisor is Associate Professor Monty Kamngan. Right now, I study in Telecommunication Engineering at Faculty of Engineering, King Mongkut Institute of Technology, Lagabang. Bangkok, Thailand. In this season, I and my coordinator would like to present the mixed mode universal filter using differential difference time connected amplifier. Okay, my outline, I have divided my presentation into 4 parts. Introduction, secondly, proposed circuit, thirdly, simulation results, and finally, conclusion of my work. So that's over for the introduction. Firstly, the introduction is you know that most of backward filter are used in electronic device, and you will find this one within electronic device that's your attention. For example, cross over network, 3-way loudspeaker. So normally the mixed mode filter are used in voltage mode, current mode, trans impedance mode, trans admittance mode. Then each of other there are 5 filtering function. So on whole is have got 20 filtering function. Moreover, the filter are still divided from input and output operation. There are single input, single output, single input, multiple output, multiple input, multiple output. Multiple input, single output, and multiple input, multiple output. While we will focus on multiple input, multiple output, and 20 filtering functions, or more than once. And then the the part of literature in 2020 by Abner with his coordinator has presented mixed mode by 2 EXCCTA, 2 guided capacitor and 4 resistor, but them use 14 resistor. Moreover, that the circuit require 2 passive component matching condition for 20 filtering function on whole mode. Next, in 2021, Alcohol with his coordinator has presented mixed mode universal filter by only EXCC2, 2 grounded capacitor and 1 floating resistor, but them got 17 filtering function. That the same year, Fast Sihudin with his coordinator has presented the mixed mode by only VD EXCC2, 2 grounded capacitor and 3 floating resistor. That the circuit required 2 passive component matching condition, and them got 20 filtering function. From the literature, we will see that the circuit used 14 passive component and many circuits required 2 passive component matching condition. So we will present DDTA or differential difference time connected amplifier for develop mixed mode universal filter. DDTA or differential difference time connected amplifier have symbol as figure 1. Then the CMOS implementation for DDTA on the right hand side, and figure 2 considers of 2 parts between lead and light. RDD is differential difference circuit and TA is task connected amplifier circuit, which combine both circuit as DDTA. Then in have got input are green circle, output voltage is blue circle, and red circle are current output. We consider output and input. We will get output equation at equation 1, while GM is shown in equation 2. And then we bring the DDTA from before slide to connect as the figure 3. Figure 3 proposed mixed mode universal filter are consisted of 5 DDTA, 2 grounded capacitor. There are 2 input voltage are green circle, 2 input current are yellow circle, 5 input voltage are blue circle, and 4 output current are red circle. Then when you consider input per output, we will get output voltage and current equation on the next page. This slide we will show 5 voltage output at equation 3 to 7, while the determinator is in the back rectangle. Next, this slide we will show 4 current output at equation 8 to 11. Then we will get omega 0 and quantity factor Q from determinator are shown in equation 12 and 13. So we are obtained 36 transfer function in 5 cases on hormone. By put input voltage and current as shown in table 1 to table 5. This slide table 6 summarize performance of DDTA for figure 3. The circuit using 0.18 CMOS technology by Taiwan Semiconductor, while the ratio PMOS equal 15 per 1 micron, and in MOS equal 5 per 1 micron. Supply voltage equal plus minus 1.2 volt, VB minus 0.4 volt. The circuit bias IB1 to IB5 equal 15 microamp. Capacitor 1 and 2 equal to 20 picofarad. From detail, we got the power consumption equal 3.31 milliwatt. The next page I will show the result of the circuit. This slide I show the frequency response of low pass, band pass, high pass, band stop of band stop filter of figure 4 and figure 5. I show gain and phase response of pass filter on voltage mode. So we found a natural frequency at 1.2 megahertz, as well as the figure 6 and 7 I show frequency response of current mode. And next slide, and figure 8 and 9 I show the frequency response on transmittance mode. And then the figure 10 and 11 I show frequency response of transimpedance mode. While we put amplitude voltage signal and current into input at 100 megahertz of the low pass filter. We get total harmonic distortion or THD at figure 12 and 13. So you will see that the figure THD less than 3% in each mode, but the the current mode is narrow length less than wanted mode. Next, the multi-color analysis at center frequency for bandpass filter with 5% variation of capacitor. The capacitor 1 and capacitor 2 and 200 Gaussian distribution run in figure 14. Show the derived histogram of frequency which show the standard deviation of frequency was 36.285 kilohertz and the minimal and maximal value of frequency were 0.923 megahertz and 1.122 megahertz respectively. And this figure is show the simulation bandpass filter with different temperature since -10 for 70 Celsius. We will see the center frequency change since 0.9101 megahertz for 1.148 megahertz. In conclusion, the proper circuit system employ 5 DDTA, 2 Gaussian capacitor, and mid-mode universal filter can be obtained 20 filtering function on whole mode. The circuit confirmed by piecewise simulation and using 0.18 micron on TSMC technology. That brings me the end of my presentation. Thank you for your attention.
Okay, thank you, Pichai. Any question from the audience? Any question? You can raise your hand or you can ask directly by turn on your microphone. Okay, Emily. Okay, you can turn on your microphone and ask him.
Slide. Okay.
Oh, okay. Can you try? Can you send your question by message? Someone chat in the inbox for the question. Okay. You see, Vishai, you see the message, the question in the message box. Are there any comparison with the literature? I mean, you compare the result, right? Compare the result with the previous work.
It's again that.
And the second question is what are the advantage of your solution? Advantage. I mean, compared to the previous work, I think. Yeah. Okay. Two question. One question. Yeah. The first question is do you compare the I think the result with the previous work? Yeah.
Okay. I compare. Please explain
compare the result. Yes. Compare the result among the previous work. Yes. But for example, in about the power consumption, PhD, and any other performance.
I don't compare
okay.
performance, but I'm trying to make a device field device. I want to field device and try to don't use and try to don't use for floating device. Right.
Okay. Maybe that is your advantage, right?
Advantage is I mentioned is issues for implementation for IC.
Mm-hmm. Okay.
Because not floating device.
Okay. You in your work you want to use only the grounded capacitor, right?
Yeah.
Okay. Okay. Any more question from the audience? Any more question? Okay. Okay. Let's I ask some question. Why you choose DDTA as active building block in this work? Why not the other device such as current conveyor, CDTA, CDBA? Why you choose the DDTA in your work?
Oh, why I choose DDTA because I think I attention that I attention that, and then I think it easy easy to realize, you know. Yeah, it's easy to realize. Yeah. And
Okay.
and easy to make IC.
Okay. 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 Any more question? Any more question for the second paper? Oh, okay. I think the time. Thank you, Pichai, for your presentation.
Thank you, Chairman.
Okay. And we are moving to the third paper. I'm not sure that they are here yet. The paper from Korea, and I know that they did not send the video clip yet. So we also don't have a video clip and presenter here, right? ใช่ไหมครับ staff ตอนนี้เราไม่มีทั้งคลิปแล้วก็ทั้งผู้นำเสนอเนาะ paper ที่3ใช่ไหมครับ งั้นนะ Okay, I think we will skip the third paper. Okay. Now we are move to the fourth paper. The fourth paper in the title of a high gain, low voltage by CMOS voltage differencing gain amplifier and application. Present by Mr. Jirawat. Okay, please play back the video.
Good afternoon, everybody. My name is Jirawat Hiranperm and Ajahn Munti Siri Pachayanan from Kim Mongkut University of Technology, North Bangkok. We would like to present a high gain, low voltage by CMOS voltage differencing gain amplifier and application. The outline of this presentation has divided into 6 parts. The first is introduction. Section 2 is show the CMOS VDGA. Section 3 show the proposed by CMOS VDGA, and then show performance of proposed circuit by simulation in the section 4. Section 5 show application as a full wave rectifier, and last is conclusion. Section 1 is the introduction. The active building block to use in this work is use voltage differencing gain amplifier, or VDGA in a shortly name. The left side is show the symbol of VDGA and the equivalent circuit. The right side is show the metric equation of the VDGA. From metric equation, the current at port Z can be controlled by external current source IBA. Current at port X can be controlled by external current source IBB, and voltage at port W can be controlled by ratio of IBB and IBC cross conductance gain of VDGA. From the periodicity report, VDGA has developed in many applications such as the loss rate and lossy inductance simulator, half wave and full wave rectifier, multifunction filter, voltage mode PID controller, current mode PID controller, oscillator, and other application. Section 2 show the circuit description of conventional CMOS VDGA. From periodicity report, the application developed based on CMOS structure as shown in this slide. The CMOS structure has consists of T group of conductance gain cell. This is the group A, group B, and this is the group C. From this circuit, the GM or time conductance gain is depend on square root function that limitation of gain. For the feature of proposed by CMOS VDGA, GM is linearly controllable, widely adjustable by electronic method, and low power voltage operation. For the proposed by CMOS VDGA. This slide shows the BiCMOS time conductance cell. From this slide, the gain of this circuit GM is equal IB by VT. The complete proposed BiCMOS VDGA has shown in the left side that also consists of T group of time conductance gain cell. This is a group A, group B, and group C. From this circuit is giving function at the VDGA in the right side to compare the CMOS structure and the BiCMOS structure shown in this table. The BiCMOS VDGA has advantage such as can be operated in a plus minus 0.75 volt. Gain control function is linear, and output can be operated in a widely length more than CMOS structure. So performance of proposed circuit by use PSpice simulation program test in this task. The parameter to use in this work is use CMOS NVL TSMC 0.35 micrometer, and bipolar transistor is used NR200N from AT&T, and power supply is used plus minus 0.75 volt. This table is show the ratio of W per L of all transistor to use in this work. The first result is show the cutoff frequency of the proposed circuit that show the circuit can be operated with about 20.25 MHz. And the left side show the frequency response of time conductance gain for differencing IB, and the right side show the gain of DC gain of the proposed circuit that show the it can be concluded that the gain of this circuit is linear and can be controlled by external current source. And this result show the DC transfer characteristic of BiCMOS relative to CMOS VDGA. This would mean the gain of BiCMOS compared to the CMOS structure. From this result, you will see that the gain of BiCMOS is more than the CMOS structure. The left side is show the output current IZ for different IBA. The right side is show the output current IX for different IBB. That means the current at port Z can be controlled by external current source IBA, and output current at port X can be controlled by external current source IBB. And this show output voltage at port W for different IBC. That means the voltage at port W can be controlled by ratio of external current source IBB and IBC. The example of application as a full wave rectifier is shown in this part. Full wave rectifier based on VDGA as shown in the left side that the circuit consists of two of VDGA. This circuit has advantages such as active only, electronically adjustable amplitude, and no temperature effect. From this circuit, full wave rectifier based on VDGA, giving current output and voltage output in the same time, as follow this equation. From this equation, you see that the current output I/O can be controlled by external current source IBA1 and IBA2. The voltage output VO also can be controlled by external current source IBA1 and IBA2 and IBC. From this equation, you will see that the voltage output has no term of VT. That means the VO is no temperature effect. And this shows the result of output current I/O and voltage VO of the full wave rectifier. The upper side is show the current output, and lower side is show the voltage output by vary external current source IBA. That means the circuit can be controlled amplitude by external current source. And this shows transient response of output voltage due to temperature. That can conclude that the circuit has no temperature effect in the pot voltage output. And for the conclusion, the BiCMOS VGA has been proposed that has advantage at the high gain and linear. The circuit can be operated with the low power supply voltage as a plus minus 0.75 volt, and the power consumption is approximate about 0.3 milliwatt. The application as the full wave rectifier has been tested. This circuit has advantage as the active only electronic tuning, no temperature effect. For the future work to find more application of the proposed BiCMOS VGA. Thank you.
Okay. Thank you, Chirwat, for presentation. Any question from the audience? Okay. Can you ask him directly, or you want to chat in? Okay. Chirwat, you see the question in the chat box.
Yes, I see.
Why is the cut off frequency lower than CMOS? Okay. Why the cut off frequency is lower than CMOS implementation?
I think because the circuit has the consist of the BJT that the main point to giving the frequency cut off is lower than the CMOS. And for the question 2, the power consumption is 2 times larger because of this circuit it use many of current source to bias the circuit. That mean the circuit is keeping more the power consumption more than the CMOS structure.
Okay. Okay. That's answer your question.
I see more question. Simulation result just before the conclusion part has this thought.
Okay.
Sine wave.
Yeah, this is the good question.
ไม่แน่ใจ I'm not sure if this mean not pure sine wave, right?
It's possible you force input for the much amplitude. Maybe.
Okay.
Okay. Thanks for your question. Any more question from other audience? Any more question? I think we have enough time because we skip the third paper. So we have about 10 minutes before moving to the last paper. Any more question? I should not ask the question because I'm co-author of this paper. So please ask. Okay, Professor Munti Kamgen, please. You can turn on your microphone and ask him directly.
Hello.
Okay, we can hear you. Okay.
I saw your result about the gain band the bandwidth of the circuit. I saw the gain is a negative. How you obtain this result?
Again, yes.
I think the gain.
Please show your the slide, your slide.
I think in slide 14 kilowatt 14 14.
Oh, I cannot
the
share.
gain is negative. Is minus of 60 decibel, right, Professor Montri?
I cannot share the PowerPoint.
Okay. Okay, no problem. You kilowatt, you can see your presentation in the 14.
Yes, I see.
54ว่าทำไม why your gain is negative is minus of 60 decibel.
Because this because the VDJ is operate in a contact and gain mode. The gain will be negative.
You mean that the output is the current, right?
Oh, yes.
For the your device is the cascade by two or three OTA, right?
Yes.
But so it should be measured the bandwidth from the input to the output. The input is the P terminal and N terminal, and the output is the W terminal, right?
Yes.
But in this result, you measure about the P terminal and Z terminal, right?
Yes.
So I think that it cannot to confirm that your circuit is operated at the bandwidth that you show in picture.
Okay. Thank you. Ajahn Monty. I understand it. Sorry, it should be test about P port to W port to test cut off frequency.
Yeah. The bandwidth should be measured from the P or N terminal to the W terminal.
Yes.
And that terminal should be connected to the load, such as the resistor, the ideal resistor. I think that. Okay, thank you.
Thank you.
Okay.
Thank you so much. Thank
Okay,
you.
thank you. Yeah, thank you. Very good. Your suggestion. Okay. Any more question? Any more question from the audience? Any more question? Okay, thank you, Mr. Chilewas, for your presentation. Now we are moving to the last paper. The last paper, title of low power, low speed, layer 2 layer CMOS buffer amplifier for flash panel display. This paper comes from Turkey that will be presented by Emre. I'm not sure. Okay. Please start playback video. Okay.
Hello. This is Emre Arslan from Aksaray University, Turkey. The topic of my presentation will be low power, high speed CMOS voltage buffer for flat panel displays. First, I want to give basic definitions of the voltage buffer. Basically, a voltage buffer, or we call this a unity gain amplifier, is a circuit which has a voltage gain of 1. There is no amplification. V in is equal to V out. Gain is equal to 1. It is generally used to isolate stages from each other. And as you can see from the circuit schematic, the most important parameters of voltage buffer are input resistance, output resistance, and also the gain. Input resistance should be as high as possible, ideally infinite. Output resistance should be as low as possible, ideally 0. And gain should be 1. So we call this an ideal voltage buffer. Here I show the small signal equivalent of the voltage buffer circuit in green box. R in and R out are the non-ideal values of this voltage buffer circuit. If you take this circuit into consideration, you will see there are two circuit parts, left-hand side and right-hand side. If you analyze the circuit, it's a very basic circuit, you will obtain V out over V in as R in over R in plus RS times R load over R load plus R out times A. If you put ideal values in this transfer function, which are R in is equal to infinite, R out is equal to 0, you will obtain ideal transfer function, which is equal to V out over V in equals to A. Now, liquid crystal displays an LCD or LCD. An LCD driver consists of column drivers, gate drivers, controller, and reference source. A column driver, which is the topic of this work, is usually called buffer amplifier, and it is the main block of the LCD driver systems. We call this main block because most of the performance parameters are defined by this circuit part. What are the most important performance parameters of an LCD driving system? It is the speed, resolution, power dissipation, and also the output swing. The circuit should have, or the circuit should be as fast as possible. It should have as high resolution as possible, and the power dissipation should be as low as possible, and the output swing should be as large as possible to obtain a high performance LCD driver circuit. We use thousands of output buffer amplifiers in a single LCD, and because of this, the layout area or a die area is the first important parameter. Then the static power consumption is also another important parameter because we use thousands of output buffer amplifiers. Each buffer amplifier should have static and dynamic power consumptions as small as possible to obtain totally small power consumption. The output buffer should offer a rail-to-rail voltage operation. We call rail-to-rail to circuits that operates rail-to-rail. That means if you apply an input signal which is equal to the supply voltage, if you obtain an output signal which can go as high to supply voltage, then we call this rail to rail. For example, if you are using 3.3 volt supply voltage, and if you obtain 3.3 volts at the output, then this circuit operates rail to rail. This is an important performance parameter to obtain higher gray levels. And also the settling time is also a very important parameter to obtain quicker and faster buffer circuit. This is important also because of the horizontal scanning time. Now, I want to give some numerical examples. For example, if you are using 640 times 480 pixels color panel, you need 640 times 3, which is equal to 1,320. So you need 1,000, more than 1,000 buffer amplifiers for a small color panel. This 3 stands for RGB. As you know, each pixel is formed by red, green, and blue LEDs. So you need to turn on and off each LEDs to obtain the colors. For example, if you need a white color, you need to turn on red, green, and blue LEDs together. If you turn off all the 3 LEDs, you will obtain a black color. So you need more than thousands of output buffers. So power consumption, die area, speed are very important parameters in such circuits. In order to reduce the system cost, in order to increase the reliability, you should use as high performance output buffers as possible. Now let's talk about the proposed amplifier circuit. It consists of rail-to-rail input stage. We call this also constant jam input stage, a gain stage, which is obtained by MP1, MN, and MN1, and inverter-based output stage. This is a high-performance output stage. We will talk about this stage later. Now, I want to show you the total CMOS implementation of the proposed buffer amplifier. Transistors M1 to M8 formed the constant GM input stage. As you can see, if the input signal, here you can see Vin, here Vin. If input signal is low, if it has low values, then M4 and M5 will turn on, here M4 and M5. And then this circuit part, MB1, M4, M5, M7, and M8 will operate and give you a gain at this node here. If the input signal is high enough, M3 and M6 will be on, M4 and M5 will be off, and then this circuit part formed by M1, M2, M3, M6, and MB2 will operate and will give us an output signal at this node here. M9 and M10 are used to boost the gain of constant jam input stage. The M9 and M10 formed a basic common source amplifier stage. And finally, the circuit employs a high performance output stage, which is formed by the transistors at this part here, like this. MDP and MDN are the two diode connected transistors. These two transistors are used to limit the VGS voltages of M11 and M12. We want to limit the VGS voltages of M11 and M12 in order to reduce the power consumption, in order to reduce the static power consumption. By the way, CL is used to model the loads of RGB LEDs. Okay. Now, if M11 is on, M12 is off, the current will flow from VDD through M11 like this through CL. So CL will be charged. It will be charged to VDD. Now, if M12 is off, M12 is off, M11 is off, M12 is on. If this circuit NMOS transistor is on, then the output signal through CL will go through this transistor to ground, and CL will be discharged. So the currents flowing M12 and M11 are very important because these two currents will charge and discharge the output capacitor. The most important part of this proposed circuit is the output resistance. It has a very small value, as you can see from this transfer function. Rout is equal to 1 over some GMs here and arrows in parallel. So this is a very small value. Why is this important? Because you will obtain RC time constant at the output. So if R and C are both small, then your circuit will operate faster. Now let's talk about the simulation results. I used LT Spice during simulations and AMS 0.35 micrometer CMOS module parameters. Here you will see the black colored input signal and red colored output signal. These are the colors. These are the currents flowing through the output transistors, M12 and M11, as you can see. These are the This is the charging current, the black one. The red one is the discharging current. So these currents are these currents go as high to 7 milliamperes. Okay. I want to give these two current values because these currents define also the current consumption of the circuit. These simulations are for varying values of capacitors. If you increase the value of capacitor, the delay will also increase. And these simulation results are for the tracking behavior. The input signal is 50 kilohertz, full swing triangular waveform, and the output signal, which is formed in red, tracks the input signal perfectly. And the input resistance values, as I showed you the output resistance equation, it has very small values. Here I write the values, 0.06 ohm at 100 kilohertz, 0.07 ohm at 1 mega, 0.44 ohms at 10, and 122 ohms at 100 megahertz. So as you can see, the resistance values are very, very close to zero, up to 100 megahertz values. In order to compare the proposed solution to the previously published circuits, we use a well-known figure of merit value. Figure of merit FOM is equal to CL over TS times IQ, where CL is equal to the load capacitance, CL, TS is equal to the settling time, and IQ is equal to the total quiescent current of the circuit. So from here, we can say that larger values of FOM implies better performance. These are the comparison results. These are the simulation results for the proposed solution. As you can see from here, the proposed solution has the maximum FOM value. It is around 600 highest value, which means that this solution has the better performance when compared to others. To conclude the presentation, we proposed in this paper a high-performance CMOS voltage buffer circuit. This circuit composed of two complementary input stages or constant jam input stages, a gain stage and an output stage. The circuit, the proposed solution, only has 2 microamperes quiescent current while driving a 1 nanofarad load capacitance. And the settling time is only 0.82 microseconds for full voltage swing. And the most important part of the proposed circuit is the very low power consumption. Thanks for listening.
Okay, thank you. Could you turn on your camera, Mr. Emre? I'm not sure is this correct for now. Can you turn on your camera? Okay. Okay. you have a problem both camera and microphone. Okay. Okay. Any question from the audience? Any question? If I ask, how you answer me? If I ask you some question, you will type in the chat box, right? Okay. Okay. One question. Why you use 0.35 micron technology? Because it's lower technology than the paper in 2015 that you mentioned. Why you did not use the higher technology of CMOS? This data form. Okay. Okay. Have you survey about the temperature deviation? Because I think that if we bring your circuit, voltage buffer to the LCD display, I think that the temperature will effect about your circuit. Have you survey about the temperature deviation? Okay, you did not. Okay. How about maybe the last question? How about the power consumption of your circuit? Power consumption. How many watt? You know? Oh, it depends on the current of output. Okay. Thank you for your answer. Thank you. It's a few milliwatt. Okay. Anyone have question for us the last paper? Anyone? No. Oh, okay. Thank you for your presentation. I heard from the staff of conference the certificate from the online presenter will be sent after this conference. Okay, and I think that I will close this session. Thank you for your joining us for the ECITCON conference for this year, and I hope to see you all in same conference for the next year. Thank you very much. Okay, thank you ขอบคุณนะครับ
ขอบคุณค่ะอาจารย์
ครับ
Okay. Good afternoon, everybody.
Good afternoon ค่ะอาจารย์
Okay. This afternoon we will start with the first paper is the effect of signal interval from SEMG sensor combined with the mechanical, and then we're going to the next one, the 360-degree object detection. And the third one is embodiment of interaction design. Okay. On presenter, you choose Lily for answer the question after the video clip. Okay.
Let's get started. Good evening, ladies and gentlemen. My name is Sekapong-Nonjai, and I am pleased to be here today to talk to you about the effects of signal interval from SEMG sensors combined with mechanical sensor on the classification of walking pattern and posture activity. Firstly, I will talk about introduction, secondary material and method. Thirdly, result. And finally, conclusion and discussion. Introduction. I just like to give you some background information about my paper, Surface Electromyography SEMG signal, are medical signals that are highly used in biomedical engineering research, which is an electrical signal produced during human movement. The SEMG can be obtained from muscle in various organs in the body, such as legs, arms, and etc. Several researchers have applied SEMG signal in human-computer communication. Exoskeletal robots use SEMG signal to recognize movement pattern to control prosthetics. Safety is an essential aspect of human-robot interaction in robot control. Hence, SEMG processing and classification technique must be reliable and accurate, not only the SEMG signal, but the mechanical signal can also be combined as co-processing data in motion recognition. Many research groups have combined SEMG and mechanical signal for classifying movement activities. We studied the suitable time interval, posture to the motion initiation to classify the pattern of movement activity. The studied features were extracted from SEMG and mechanical signal. The ensemble subspace discriminants was employed as the technique of classification. Right, let's move on the material and method. Our research methodology overview can be illustrated as the box diagram. There are 4 main stages, including data collection, signal processing, feature extraction, and classification. In the first part, data collection, one subject in this preliminary research. The data collected from 2 symmetry devices, including 2 channels of SEMG, 3 channels of the accelerometer, and 3 channels of gyroscope with 1 kHz sampling rate. This study considers 7 movement activities, consisting of level walking, ramp ascent, descent, stair ascent, descent, sit down, and stand up. Each pose was collected 50 times. The stair angle is 55 degrees to the horizontal with 150 centimeters in height. The ramp pass was an angle of 10 degrees to the flat. Data was selected for 10 seconds per posture from the right leg. This figure A shows the mounting position, shimmer tree with accelerometer and gyroscope are also included in shimmer tree. The SEMG mounting position shown in figure B has the GAS position, VM position, GA positions, and HAM position. Next part, signal processing. We sequentially filter as data from shimmer tree to eliminate all noise using bandpass filter with a bandpass filter frequency of 20 to 500 Hz and noise filter at 50 Hz. This figure shows the example of collected data, including SEMG signal, gyroscope, and accelerometer signal through a filter. The beginning of SEMG signal is used as the initial of its movement activity computing with the file change EPTS function in MATLAB. To find S-dot change in a signal. 4-time interval after movement initial was copied for this study. That was 500, 1000, 1500, and 2000 milliseconds, as shown in this figure. The purpose of this paper is to investigate the appropriate range of study signal for motion classification. The next part, feature extraction. This research analyzes SEMG signal, gyroscope signal, and accelerometer signal in the time domain by extract the feature, means absolute value, waveform range, slope side change, and zero crossing. The last part, classification algorithm, assemble subspace discriminant, is a subspace learning technique to improve the accuracy of LGS analysis. Can be analysis in the row dimension data. Also, this algorithm uses less processing memory. The principle is the select a random subspace method from the possible value and then train the weak runner data. It repeats random data and train the model of weak runner until there is no weak runner before making decision. The prediction principle uses the mean of weak learner predictive score by majority voting methods is used and classes the category with the highest average score to create model. Right, let's move on to results. Results are presented in this section. This paper is study of 4 different time intervals after starting activity. The classification result with 10 first chord validation are shown in this table. The results show that using data from both muscle and mechanical sensor yield the more effective activity recognized result. The range of the signal interval also affect the recognition of posture. From analyzing the signal range of 2000 milliseconds by all sensor achieve the best result with an accuracy of 97.09 plus minus 0.29%. However, when considered the shorter signal interval of 1000 and 1500 milliseconds, the classification result was slightly different from the analysis with 2000 milliseconds of signal interval. This figure shows correlation metric of the classification with varying interval of time. The experiment found that the proposed method was able to well recognize for sitting down and stand up posture for all study time interval, while the posture of walking on land and stairs still have some classification error. Here is the last topic, conclusion and discussion. This paper presentation our preliminary study on the classification of posture with SEMG signal and mechanical signal 7 movement activity. 4 different time intervals after the beginning of posture, including 500, 1000, 1500, and 2000 millisecond interval. The result found that using SEMG alone in posture analysis was the less accurate compared to analyzing SEMG signal in combination with mechanical signal. Posture recognition with 2000 millisecond signal interval gave the best result. The range of the process signal may affect the speed of exoskeleton control with the necessary for future research. We will use more data selection from more sample subjects, select another analysis, and enhanced classification method to be applied in exoskeletons more efficiently and in the real time in the future. Thank you all for listening. It was a pleasure being here today.
Good morning. My name is Alaya.
Okay. We still have time for the question. May I ask all participants turn on your camera? And if you have question, you can ask the presenter. There are no question from the audience. May I ask a question? Who is the presenter? Okay, Mr. Jakapong, right?
Yeah.
I have 2 questions related to your presentation. One is why do you select this assemble subspace discrimination method for your classification problem? What is the reason for that?
Because I select many method to classification but ไอ้ตัว but discriminant have high accuracy to classification in this work.
Do you have any reason more than just try several methods? No.
Again.
Do you have any reason apart from the experiment? Maybe you may know the merits of this technique before you can use it.
I compare many methods to classification in this work, but classification assemble subspace discriminant is a high accuracy.
Okay.
I choose
Thank you.
algorithm.
Okay. I have one more question about your bandpass filter and knock filter. You said in the presentation that you used the bandwidth of the bandpass filters between 20 Hz to 500 Hz, right? However, the knock filter is 50 Hz, which is in between the bandpass frequency. How did you do that? Why did you do that?
I select bandpass filter from reference in the reference research. Another research I reference that and apply to this work.
But if you select the knock filter in between the bandpass filter, is it not disturb some data that you want to use in 50 Hz?
50 Hz.
Yeah. Because knock filter will cancel out that signal in that frequency, right?
Yeah.
So what is the reason why you select knock filter at that range of the frequency?
I need to reduce frequency to 50 Hz because frequency to 50 Hz is a noise to a symmetry.
It's a hum noise, maybe. Okay. Yeah. Thank you for the presentation. Maybe we go to the next presentation. The next one is 3 degrees detection using multiple TOF sensors for educational robot. Okay. We can start now.
Good morning. My name is Alaya Gomhet from Kasetsart University. Today, I would like to present my paper titled 360 degrees object detection using multiple TOF sensors for educational robot. First, I will introduce you about an educational robot. Presently, educational robot plays an important role in robotic programming class because it can show the programming process. It motivates students to learn new technologies and it helps students to improve their skill. For robotic class, there are many types of robots are used. For example, an omnidirectional robot is popular because it can move in any direction, so it's suitable to use in small area like a classroom. However, the damage from collisions between robots may happen. Therefore, the object detection system must be used, especially in a movable robots. And it also used for teaching students about a fundamental of programming and sensors. Object detection is important for a movable robot. For omnidirectional robot which can move freely, it requires 360 degrees object detection. In this paper, the object detection system is designed to detect objects in 360 degrees. However, it only focuses on the position of object rather than their type or shape. Infrared and ultrasonic detection are commonly used for object detection. However, many studies show that infrared is more effective in terms of accuracy, speed, and less interference. In this paper, time of flight or TOF sensor, which is an infrared sensor, is used in proposed object detection system. Time of flight is a technique to determining the distance between by measuring the reflection time of the signal from the object to the sensor. Some studies have used TOF sensor for 360 degrees detection. For example, a TOF sensor is mounted on the motor to rotate for detecting objects. However, this method requires more complicated processing and requires energy consumption to supply power to turn the motor all the time. Another example is a link of 16 TOF sensors. However, this design uses too much sensors. This means that the robot needs more space to install all sensors. Therefore, it is not suitable for a small robot. In this paper, with L53L5CX, a multi-zone ranging TOF sensor is used. A dimension of sensor is shown in this picture. Next picture is shown a field of view or FOV of the sensor. It provides a field of view 45 degrees with a length of up to 400 centimeters. This is ideal design. It uses 8 TOF sensors with a 45-degree FOV to operate in 360 degrees. However, in practical, sensors have dimensions, so they cannot be placed in the same position. This is design considering the dimension of sensor called simple design. Sensors are arranged in a ring. The green area represents a detecting zone, while the gray area represents a blind zone. If there are an object in gray area, it will not be detected because the green area don't overlap. This picture shows that X sensor cannot cover 360 degrees anymore compared with the ideal design. So it needs more than X sensor for this design. This equation used to calculate distance between a sensor and the center point, which is R. W is the width of sensor and N is the number of sensors. This equation is from the apothem formula of a polygon. For a geometric of symbol design, you can see that all green area overlap at this point. In this paper, the distance between the center and overlap point is called the operating point, which the point is the system can cover 360 degrees. The operating point is calculated by this equation. That calculated by the trigonometry is shown in the right picture. This graph plots between the number of sensors and the operating point. You can see that when the number of sensors is 8, the operating point is infinite. This means that the detecting zone don't overlap, so it cannot cover 360 degrees. This design requires at least 9 sensors. However, is not suitable for small robots because the operating point is too much. When the number of sensors is 16, it provides the best performance in terms of the closest distance. However, from 9 to 10 sensors, the operating point decreased significantly, almost 50%, while the number of sensors increased only by 1. On the other hand, the operating point decreased only 30%, while the number of sensors increased from 10 to 16. Therefore, this paper selects 10 sensors to use in the object detection system. This design called double layer design. For this purpose design, sensors are arranged into 2 layers. There are 5 sensors for each layer. For the first layer, the distance between sensor and the center is calculated by the same equation as symbol design, where the number of sensors is 5. The sensor in the second layer need to be placed close to the first layer to minimize the operating point, but they must not be in the detecting zone of the first layer. R2 is the distance between the sensor of the second layer and the center. It uses this equation to calculate. This picture shows a geometric partial double layer design, including 2 sensors from the first layer and 1 sensor from the second layer. The operating point of double layer design, or RDL, is calculated by this equation. For the proof of this equation, they are calculated by the trigonometry shown in the right picture. This table compares the performance between symbol design and double layer design. You can see that double layer design provides better performance. It requires only 1.6 centimeters from the center for placing all sensors compared with 2.6 centimeters of simple design. Moreover, the operating point of double layer design is 6.9 centimeters, which is lower than the simple design allowed 45%. To test performance of double layer design, the experiments are conducted. The partial double layer design is installed on the top of omnidirectional robot. For the experiment, the object placed in front of the robot, and the robot is programmed to move and stop moving when it detects the object at distance 15, 20, 25, and 30 centimeters. This graph shows the distance between the object and robot for each travel. Green line shows the distance between the robot detecting object at 15 centimeters. Red line, yellow line, and blue line represent 20, 25, and 30 centimeters respectively. This table shows the average distance and percentage of errors for each case. It can be seen that the robot stopped move before the reaching object, except for the case of 15 centimeters, and the percentage of error calculated is less than 5% for all cases. The proposed double layer design can perform in an object detection system that can cover a wide variety of distance while minimizing errors. In addition, it outperforms simple design. To reduce error, the design must consider the hardware limitations such as the electromagnetic interference, the robot's figure, and the size of robot. Thank you for your attention.
Okay. Yeah, Miss. We have a question from the audience. Can you turn on your camera and ask the question? I saw one audience who raised the hand. Oh, you just approached. Okay, sorry. The audience, do you have any question about this presentation? No question? If you don't want to ask personally, you can write down in the chat. Okay. If there are no question from the audience, may I ask a question, Miss Araya? Okay. I have a problem about your summary of the error of your measurement. If you remember in the table that you show the error, yeah, there are only negative % error. But why is that? The error always be negative only?
I show that because I want to show you see that the result is if it's negative, it if it result is error is negative, isคือมันคือถ้าสมมุติมันเป็นลบอะค่ะถ้าสมมุติ error เป็นลบอะค่ะคือก็แสดงว่าหุ่นยนต์อะค่ะถึงก่อนที่จะถึงจุดจริงๆอะค่ะแต่ถ้า error เป็นบวกค่ะมันก็คือจะถึงหลังจากที่ถึงแล้วแสดงว่าอันนั้นน่ะค่ะคือเป็นผลที่ผิดพลาดอะค่ะ
Yes, but how many tests that you use for each distance?
We test 10 trial for each distance.
So you measure only the case that the robot not reach the certain distance, right? But for the first case, which is 15 centimeter, is there any case that robot cannot reach the distance?
หมายถึงว่า
Because you show only one error, which is 1.33% error, right? And in your video, you said that this is the only case that the robot go beyond the set point.
Yes, เป็น it one only case that the robot คือ the robot is ถึงเจอวัตถุหลังจากที่จะหยุดแล้วอะค่ะคือค่ะ
Only this case. Do you know the reason for that?
คิดว่าอาจจะเป็นที่ time processing ในการส่งข้อมูลค่ะว่าถ้าสมมติเซนเซอร์อ่านไปแล้วเซนเซอร์แบบพอสั่งให้หุ่นยนต์หยุดอะค่ะคือเพราะว่าหุ่นยนต์พอระยะทางมันใกล้มากๆค่ะอาจจะสั่งไปให้หุ่นยนต์หยุดวิ่งไม่ทัน
Okay, you mean because of the sampling time that you use for the robot is not fast enough to stop the robot before the robot go to the set point, and this happened because of the distance is too short, right? Yes. Like that. Okay, the time is up. We cannot have more question than this. Okay, thank you, Miss Araya, again for the nice presentation. Okay, the next presentation is from Fibo, I think. The title of the paper is embodiment of interaction design for the companion social robot. And the presenter is Mr. Pasakon Attana Gun Walanon. Okay. We can start the video now.
Good afternoon, the ETCI Conference 2022. My name is Pasakon Attanagun Walanon from the Institute of Field Robotics, King Mongkut, University of Technology, Thonburi, Thailand. Today I'm presenting my research topic named The Embodiment Interaction Design for Reception Robot. In this presentation, I will start with the introduction by talking about the objective and scope. Next is methodology, talking about movement robot design, the tactile-based interaction, the perception, the emotion architecture, and system integration. and the last is experiment. Start with the introduction. The objective of the research is we want to create a robot with a unique appearance that embody biological-inspired physical interaction. So if the robot can be soft, we use the soft material to inspire the people that robot is not a hard thing and robot is safe with the comprehensive actuation and perception sensor and study how people interact with this type of robot. So the scope of this research is to implement the upper body part of robot named Moomin, which the UX design collaboration from KMUTT University Architecture Design team, and we focus on the physical interaction between human and robot, such as hugging or head patting. Next part is methodology. The robot Moomin is designed to have soft and compliant body part, which will promote a safe and friendly appearance when interact with humans. One of the unique appearance of this robot is having the upper ear that's similar to the animal ear, and it also has lower ear that's similar to the elephant trunk, which can be used to imitate arm gesture of an anthropomorphic robot. The prototype of Moomin robot is only its upper body parts that are necessary for performing expression are built. It consists of head, the upper ears, the lower ears, and the neck joint. The picture on the left side is the robot UX design from the architecture team, and the picture on the right side is CAD engineering implementation based on UX design. So the lower ear and upper ear compliant mechanism is the part that gives Moomin distinctive looks. The continuum robot mechanism is selected for the lower ear, which advantage in its flexibility and elastic body. We designed the continuum robot based on snake arm robot by reference number 4. On the right picture is the design that we came up with the upper ear. The upper ear is made of the 3D printer TPU materials compliant skeleton. This structure is flexible mechanism that achieve force and motion transmission to the elastic body deformation. The compliant mechanisms are designed using topology optimization of the structure. Next, we need to know how the soft robot movements, the compliant lower ear and upper ear, express the basic emotion. First, we come up with the concept design of movement expression, the happy, sad, angry, and confused, and one gesture, greeting. So we create the simulation to design the motion of the continuum manipulator based on the kinematics model on the right side below. The purpose of the simulation is to select the set of the control parameters that best represent for each expression. The control parameter of the continuum manipulator consists of S is backbone length, K is the backbone curvature, and theta is the direction of the backbone curvature. And the result of the kinematic model simulation is shown in the picture on the left side below. The next part is perception. The robot is designed to encourage physical interaction between human and robot, so it is important that the robot is able to perceive interaction from human user. As it is destined to be used in reception, we decided that the robot should have ability to perceive action like a hug, a pat on the head, and squeeze on the lower ear. In order to create the perception, variant sensors are used on the part of the robot. First is IMU for indicate checking and lifting of the lower ear, using its ability to measure acceleration and velocity in the three-dimensional space to estimate the movement of the lower ear. Second is lens sensor time of flight on the forehead indicate the presence of any object in front of the robot. The other lens sensor under the chin specify the action of chin scratching. The last is tactile sensor pad. Based on the reference number 5, the sensor is used to perceive patching, touching, slapping, pitching, and squishing from the human user. For detail on hands-on tactile sensor pad in reference number 5, using a characteristic of piezoresistive polymer sheet, where it decreases its electrical resistance when force is applied. We can measure the change of the resistance by creating a texel. Placing electrode under and above the sheet, there are 4 texels on each fabricated tactile sensor pad. For sampling and changing voltage over a texel, a demultiplexer selects a column electrode and connects it to the voltage source. Meanwhile, after demultiplexer connects a low electrode to the electrical reference, and an analog to digital converter is then used to sampling and convert the voltage over the texel before it goes into the MCU. The next part is emotion architecture. The interaction of moving robot is based on the emotion architecture proposed by reference number 6. The emotion architecture used to classify physical interaction and create the system that allow a natural human-robot interaction. The emotion of reception robot is decided to respond to the physical interaction from a user, which is perceived via multiple input sensors. A classification module is used to translate the raw sensor data to the type of the physical interaction input from the user, such as hugging or head patting. In this part, the proposed emotional expression of each robot is individual unique since it is created from a predefined personality and the mood of the robot at the moment. The next part is system integration. There are 3 main subsystems in moving robot. These operations are implemented on ROS framework. First is perception node run on microcontroller number 1. Connect with 5 tactile sensors, 2 time-of-flight sensors, and 2 IMU sensors. The MCU reads all sensor data and publish to the main MCU using ROS serial. The second is ROS Master, the main system of the robot, implements on Raspberry Pi 4. Subscribe to all sensor data from the perception node to calculate the robot interaction using emotion generation node. From the output of the emotion generation node is the gesture data published to the render face node to render and display the robot face animation on LCD monitor, and publish to the interaction node using ROS serials. The last is interaction node. Subscribe to the gesture data to calculate the trajectory of the upper ear, lower ears, and the neck joints by using cubic polynomial trajectory generation and control parameter of the continuum manipulators that memorize on the MCU. The last part is experiment. In this project, we implement during the COVID-19 pandemic restriction, so no one came to the university to test the prototype of the moving robot. We can only evaluate how users perceive this expression display based on non-physical interactions method using video and online survey. On the right side is the video that we use in the online surveys. The video shows the 5 actions of moving expression display. After they watch the video, they have to answer the survey in the Google form. From the experiments, there are 2 sets of questions. The first one is to evaluate the general opinion of the participant toward the command design and expression display of moving robot. The question 1 is, what do you think about moving robot expression and movement? And the question 2 is, how does the command design make you feel? The result from the first set of questions. User participants think the command design looks friendly and safe for 71.5% agree, but they mostly feel neutral for 61.5% in terms of the novelty of the design. The second set of questions is to measure how well designed expression display is correctly perceived and interpreted by human observers. The results from the second set of questions show the valid correlation between proposed expression and answer of the participants. The accurate answer are 42.3% on greeting, 83.1% on happy, 92.3% on sad, 96.2% on angry, and 96.2% on confused. The correlation score of greeting is lowest, which might be caused by the facial expression that can be confused with the happy expression. For the conclusion, this kind of robot is very new, and we want to introduce the new reception robot that based on the concept of embodiment interaction, where robots can interact and respond to the user based on tactile perception, such as hugging, patting, and hitting. From the experiment, the Moomin robot showed that users feel friendly and safe, and users can understand the gesture, happy, sad, angry, and confused correctly, but not clear in greeting gesture. In the future, a soft surface skin will be installed on the robot and will be integrated with the flexible tactile sensor and compliance mechanism, and develop the lower body part and test its performance in the realistic environment. Thank you very much.
Okay, thank you. We still have time for one or two questions. The audience, do you have any question about this robot? No, I choose to ask the question again. Okay, the Moomin robot is very cool. Yeah. I have two questions. One thing, what is the objective of Moomin robot?
The objective of the mobile robot is to make the new reception robot that based on the tactile perception and the soft mechanisms. Because from the last robot we in Fibo we create the hard robot, the the robot called Namo, and the teacher found that there are space between human and robot. So to make the user can play and can interact to the robot with the friendly. So we do the new robot by the new concept with design from the UX first, and then use the mechanicals to solve the problem.
So you mean you design this robot to use to be like a friend of human?
Yeah.
Right.
Used to be friend.
I have another question. How did you get the movement of the 4 basics emotion of the robot? You decide by yourself, or you?
Yeah. I design by myself. First I come up with the design on the sketch of the expression of the like happy, sad, angry.
But how do you know that for example, Anki, you need to move the hair of the robot like that?
First we design based on when I design the concept design of the expression, I ask my friend and show the picture of the design, but and ask the teacher.
That's why when you test the getting emotion with the people, and people still confused, right? Because the movement of the robot is not standard.
Yeah, yeah.
Okay, maybe that is the reason.
Yeah.
Okay. There is another question from the audience.
Okay.
Can you turn on the picture? Okay, you can start asking the question.
I would say that the robot would look nice. And I have a question. Would it be beneficial for you to use the robot for people with depression because they would have a friend to stay with? Okay. And that would be a good application for it. Do you have any ideas for further application for using the robot?
Okay, so in the future, we will make the soft skin of the robot and do the lower body part of the robot as shown in the UX design on the first slide.
Okay. That's nice. Thank you.
Okay, thank you.
That may be dangerous when you use the robot with the depressed person. It may make them more sad. Yeah.
Yeah, because this robot is very sad body.
Yeah.
That is biological inspired.
Yeah. Okay. Thank you for the question and the presentation. Okay.
Thank you.
Next presentation is from Japan. It's the prototype of a build next robot for miniaturization. The presentation is Yuki Kato. Okay. And start the video.
Today, I'd like to talk about prototype, wheel type, snake type robot for miniaturization. The flow of the presentation is as follows. Background.
Okay. Thank you for the presentation. Okay, Mr. Yuki, you are here, right? Okay. Yeah. From the audience, do you have any question about the snake robot? Okay. Miss Prim, right? Do you have any question?
Yeah.
No. she just give you a. You have a question. Yeah. And you can act now.
Can you hear me?
Yes, I can hear.
We can apply the robot into the real world situation how could we apply it? And have you ever tried it in the real world situation?
Situation.
Have you ever tried your robot with the real situation?
Front.
Maybe he doesn't hear your voice. Can you ask again? Okay.
Hi, can you hear me?
Yeah.
Okay. Have you ever experienced your robot in the real world situation? And what application would you like to apply it to? Like, how would you use your robot? Yeah, I found it really interesting to have the snake robot.
Mr. You can speak now. Mr. Yuki?
Yeah.
Oh, in the factory, right?
Yes.
Oh, what kind of industry, like the factory? Would it be helpful?
Another under the floor. Sorry.
Maybe we can use the snake robot in the area which is very narrow. This is in the factory. There are a lot of area which is very narrow, and we cannot use the big robot to carry some equipment, right? Mr. Yuki, you say something.
Situation is disaster.
Say something. Maybe we can help you, or you can type the answer in the chat. Okay, maybe because of some communication. Thank you. Maybe you can send email to the other to ask question, and maybe he can reply you by email. Okay. Yeah.
Okay.
The time is quite limited. We need to go to the next presentation. Okay. Thank you. Thank you, Mr. Yu. The next presentation is from KUTT. The title is Study on Deep Reinforcement Learnings for Mobile Robots. Walking control in uncertainty situation. Okay, you can start the video now.
Good afternoon, committees and author presenters. My name is Prakorn Kalkem from Department of Control System and Instrumentation Engineering, Kim Mongkut University of Technology, Chonburi. Today, I will present a study on deep reinforcement learning for mobile robot walking control in certain situations. The content from this paper had 5 contents. The first is an introduction. The second is a related work. The third is the proposed methodologies. This work use multi-agent deep deterministic policy gradient to solve this problem. The first is a simulation. It has a simulation setting and a simulation results. And the last one is a conclusion and discussions. The introductions. Nowadays, robots are very important in a daily life and the industry because robots don't have any feeling and emotions in their work. So it cannot continuously with content efficiently compared with humans. For these features, this is a global robotic market for 2018 to 2022. The market is expected to grow to 77 billion in 2022, and increment will go up to. It means robotics is a very important nowadays, and the market will grow to next year later. One of the popular techniques for solving the mobility problems of the mobile robots is machine learning, which are the machines to learn by themselves. In the machine learning, have 3 main points that are supervised, is used by task driven. The next is unsupervised, is used for data driven, and the last one is reinforcement, is learn from mistake. That is for the paper. I will detail on the reinforcement learning. The related work in reinforcement learning is suitable for solving problem of mobile robots because reinforcement learning is ideal for problem solving in the real world environments without teaching or pattern of data. In 1992, Walkins proposed on the Q-learning model of the reinforcement learning. The agent selection action and the current condition of the environment are used to store the Q-value. And in 2010, James Peter proposed a reinforced that is a multi-color with policy gradient algorithm in reinforcement learning, when the agent uses policy to correct sample episode. Okay, let's go to next. The next is a deterministic policy gradients, and it will improve to deep deterministic policy gradient. But I will detail on a deterministic policy gradient first. The policy gradient is proposed by David Silvers in 2014 for dealing with continuous action space. The deterministic policy gradient is better than the speculative policy gradient. It's simpler and it can be computed more efficiently. The update action value functions of a DPG with on polarity and off polarity are on the same as the popularity weight and the target network, and the actor is updated by following apply to the chain rules of the expected return from the start. After deterministic policy gradients was proposed, newly Kraft et al. In 2016 extends deterministic policy gradient by combining the main idea from deep Q network into the deterministic policy gradient. It's called deep deterministic policy gradient. It is using experience replay memory to store path transitions and learn of polarity and target network to stabilize learning. And in the related work, the applications mobile robot with reinforcement learning, I will give you four or five example papers. The first is a lecture et al. Propose decentralized reinforcement learning to control mobile robot in the 3D environment. The Robert and Doshis propose inverse reinforcement learning that's controlled with the multi-robots to estimate situations by looping robots into an unknown area. The Gronak and stem cells use a proximal polarity optimization algorithm to control a mobile robot to reach to target with agreed world environment. Yeheskel et al. Propose Q-learning to rising for June autonomous robot for moving in many informations with itself and simulate in the real world. The last one of the example is a Carucho et al. Use deep reinforcement learning to control the MIMO PID of a mobile robot for reach and avoid obstacles. It uses inverse of the DPG to this work. We will go to proposed methodologies. In this work, we use multi-agent deep deterministic polarity gradients. It can call MADDPG. This algorithm is developed by Rowe et al. He analyzed the difficulty of a deterministic policy gradient in multi-agent case that will use a lot of polarity information when using many agents. They use decentralized actor and centralized critic on the observations and actions of our agents. The first step of the MADDPG is computing a noise with episode loop as a random number of action explorations, and then the system will receive initial state. The second step is going to the agent step loop of observations and select action from the polarities. But the polarity has a noise too. Then the actions, observations, and rewards will be executed from the story relay buffer D. The new state instead of the old state. The first step is doing with agent from 1 to n. After that, the agents generate experience K from relay buffer D and set terminal differential order as a TD order from the polarities. Then the TD order is calculated from the reward and Q value state and all of action from agents. When new action from the mini batch K is a new polarity from observations. And then the next step is to update the critic by minimizing the rod functions and the actor by using sample polarity gradient functions. Lastly, new target network parameters update for each agent multiply with the learning rate. If add with a new target network which multiplied by 1 minus the learning rate. And the right picture is an overview of multi-agent with a decentralized actor and centralized critic. Then the state, actions, and reward function of the algorithm. The state is contain the robot positions, robot velocity, target positions, and robot obstacle positions. All of the positions contained on the x and y coordinate. The velocity correct by left and right velocities, same as the actions. action is in the action it have a two action on each robot. There are the velocity from the right view and velocity from the left view. And reward functions have in this work have a 5 main points. The first is a robot can reach themselves to near the target that we expect. The second is a robot collision with themselves, we will penalty them. And the next is a communication between robots. The fourth is a robot collision with obstacles, and the last is robot speed smoothly. For the simulations, in this work, use a 2D world form simulations by MATLAB assembling software. The area of the simulation is a 6 multiplied by 6 from the minus t and t of the x and y axis. The robot we will use is a total but 3. It have a view radius is a 0.0335 and view length of 0.167 and the weight is 1 and speed is 0.22. The target position, target area, the robot position, and obstacles if used in a certain situation. That is the same when the reset on the next episode. The position of all is used in x and y coordinates. The result from the pictures. Okay, the x is episode and the y is reward. In the result show the 3 rewards. The first is episode Q0 or predict and a future reward of the critic in yellow. The orange line is the average of the reward and the last episode reward in the blue line. The result from the episodes can tell us that reward can get higher from the earlier, which means the robot will succeed if our enough strength, the suitable reward, and the problem systems. The episode rewards mean what are the robots move is better or worse performance in that episode. And the average reward means the average robot performance that can go to a target, maintain distance between themselves and avoid collision or not. In the episode Q0, that isn't get higher or lower from the start to the end of the simulations. It can tell that robots can get better performance than the earlier episode. Which robot simulations from the average reward it doesn't get a higher results too. Conclusion and discussions. The MADDPG is a better suitable because this algorithm improved from the DDPG by using centralized critic for the analysis of all information in the environment and decentralized actor to reduce action matrix size within its theories. The result of our algorithm it doesn't reach robot to succeed on objective. It may be a problem with the simulations. The future, the first we will fix the result of this work to expect result to regular reinforcement learning. Then the certainly has a good result. We will simulate at uncertainty simulations. After that, we will implement with 3D real world for test performance. Lastly, we will improve the experience replay for better performance. Thank you for attention.
Okay. The audience, do you have any question about this reinforcement? No? Please help me. Okay, this is quite theoretical work, right? I have one question about that. You said that you're going to apply this technique for the total robot, right?
Yes, that's right.
Yeah, but in your simulation, you use MATLAB and simulating. Do you have the model of the total robot or not?
Yes, we have a total robot, but I didn't use it in the simulation as a 3D for the next my simulations. Because I want to check my algorithm to the good performance first, and then I will use it to the simulation as a total bot and real world as a total bot too.
Okay. So in my opinion, in simulation, maybe you can control all environment of the robot, but in real life, you may have the problem with uncertainty of the robot machine, right? The motor maybe not work as you want. So do you have to prevent such problem before you apply your technique to the real robot?
Okay. Wait a minute.
Yeah. Basically, I asked about is your algorithm is robust enough?
I think it's I will improve it to the robust and better performance.
So in your result, is it not robust yet, right?
Yes, that's right.
In your simulation, you didn't apply some uncertainty to the robot. Is that right?
Yes.
Okay. So the next step, you need to apply some uncertainty to your model. Okay. I think the time is up. I may ask all audience to turn on your camera to take a good photo together. All presenter, yes, very honored to see your face from the camera. Who will take the photo? Jan Pirayut, you take the photo, right? Ajahn Israpong, can you turn on your camera? The co-chair. Okay.
Sorry for late coming, sir. I have the class.
Yeah.
You
The other doesn't want to show the face. Okay, I think all presenter. Who will take the photo? Jan Pirayut?
Yes, we have a group photo and we have a record for this session
Okay.
already. Okay, thank you, Ajahn Suchai Wuto.